Okay, we're on page 2 here. Let's take a look at this definition. It says an equation whose variables are, and we'll fill that in polar coordinates, whose variables are polar coordinates, is called a polar equation. The graph of a polar equation consists of um, all points whose polar coordinates satisfy, oh, if I could spell it right here, hang on a second, satisfy the equation. Okay, so here we're going to be graphing some stuff, and we are going to get into quite a few graphs. I'm going to move over here so you can see, like we're going to get into all kinds of graphs. I'm not expecting you to get to the point where you are completely proficient and able to, off the top of your head, know it. We do want you to recognize it. These first couple that we're going to go through in these notes, you do need to be able to pull those. Okay, but once we get to the fancier graphs, I'm not really expecting you to have any kind of memorization or construct of that necessarily. All right, so number one, identify and graph polar equations by converting to rectangular equations. Identify the graph of the equation r equals 3. Use the techniques from the last section to convert the polar equation to a rectangular equation. Remember last time when I told you there's two routes? You could either square both sides or you can multiply both sides by r. And the reason why we would multiply both sides by r is if I have like a sine or a cosine in there. I don't have a sine or a cosine, so I'm going to go ahead and square both sides. So r squared is going to equal 3 squared, so r squared is equal to 9. Well, we also know that r squared is equal to x squared plus y squared, okay, because of, right, the Pythagorean theorem. Here was r, here was y, and here was x. So if I take this part of this and this part of this, remember the transitive property, if A is equal to B and B is equal to C, then A is equal to C. Well, here's my B right here. R squared. Both of those are equal to it. So I can write x squared plus y squared equals 9. And this should take you back to maybe geometry, possibly algebra 2. This is definitely the graph of a circle. Okay, so when I have a graph of a circle, this on a polar coordinate, this number, the number 9, is the square of my radius, right? Remember I said r squared is equal to 9. Um, so if I take the square root of that, I get 3. So that's going to be the radius of my circle. And because I don't have any, x minus or plus anything and y minus or plus anything, it's going to be centered around the origin. So 1, 2, 3. This is going to be a graph essentially that goes around. I apologize for not being able to do it all that great. A little bit off, but it's going to be the graph of a circle. So not too bad. Okay, let's move on to the next one. Example 2. Identify and graph the equations. We have r sine theta equals 2. Do you remember what we can substitute r sine theta with? That's right, it's y equals 2. So there's no variable of an x or anything else. So what I'm going to do is I'm going to look for 2, which is right here, and I'm going to end up graphing a line at 2, at y equals 2. So this is going to be the graph of a horizontal line. Okay, so if you have just r sine theta, you would have equals 2, you would have a horizontal line. If this 2, was a 3 or a 4 or a 5, you would just move it up, or if it's less than that, you would move it down. Okay, so there is our first page of graphs.